We are in New York Tech, this wonderful university that has many campuses, because I know that you have a campus in Manhattan, another one here in Long Island, but then also in Arkansas, and also one campus in Peking. So you have international students and very advanced equipments like the ones we are speaking about today. And I can see some 3D printers here, and also some wonderful objects. So I'm very happy to have here the Dean of the School of Design, Architecture and Design, Maria Perbellini, and I'd like to ask her to tell us how this wonderful laboratory was born, and what are you doing with the students here in New York Tech.
Thank you, Director Finotti, for visiting us in our campus in Old Westbury. Our School of Architecture and Design at New York Tech has two major campuses, one in New York City and one in Old Westbury, where we are right now. And this is actually Education Hall, which is a beautiful historical building where the School of Architecture and Design has studios, classes, and this newly renovated and expanded fabrication lab housing and is the home of our emerging technologies. It has been possible, this beautiful facility was possible thanks to the grant that we received from the IDC Foundation. Is an incredible foundation that is supporting the vision of our school, particularly with the relationship to emerging technologies, infusing all our curricula from day one. Our students at the freshman level, they come here and they have this intersection and infusion of fabrication and digital fabrication, 3D printing, robotics, CNC machines, laser machines, and many other equipment and tools that is really transformative in the way how design is conceived, is part of the idea of design already from day one with the association of computer, machine, and hand drawings. We still have hand drawings.
You have a sort of combination between analogical and digital processes, and also manual ones, because I've seen laboratories where it was like going back to the old capacity of hands of working. So you are able to create a connection between different languages. And I know that you have some very technological 3D printers which are Italians. We are going to see at least one of them.
It is absolutely essential for the student when he's learning about making and about drawing and about architecture and design to have a back and forth process between what is analog and what is digital. It is important to take out of the computer the drawings and test the drawings in scale, with proportions, with materials, with assemblies, logic, and being able to see the space through the models that they make. The digital tools are helping to push the boundaries of innovation and exploration of spaces. And is a process of thinking, is a process of critically thinking about the space that we want to inhabit. Yes, the 3D printing technology that we have is really something at the forefront of emerging technologies. And we have WASP, the machine that can reproduce in scale 1-to-1 components or entire pieces that can be assembled
and it is
together.
Italian.
And is Italian. Mm-hmm. And it is an incredible collaboration, very innovative and very visionary about the future of what we can do through a machine connected to design and to other tools of exploring spaces and simulation as well.
What are the advantages of a 3D in comparison to the older systems?
we can really explore several and different materials at different scale. And from a really small component until one-to-one scale, full object. And product design, for example, is playing a big part in our explorations in terms of architecture, interior design, product design, industrial design. We have so many paths that we are exploring at the moment. Materials, they play a big part in design thinking and critical thinking. And we have several kinds of plastic, for example. We can work with clay, we can work with resin, we can work with metal. There is really a big range of materials that we are applying and exploring through those machines. And we can create unique pieces.
Exactly. So this is a big difference because you don't need to have a big industrial production, but you can explore different materials, but also different shapes.
Yes.
With only one machine. And how do you choose your machines? I mean, the ones that come from Italy in comparison to other ones. Do you have sort of exhibitions where you go and see the different possibilities that you have?
We have an incredible faculty that are visible. They participate to conferences, they participate to collaborative research projects, and they really expand. They're reaching out to new technologies, to innovation, also not just in the United States, but I would say globally. And they see things, they see what is going, what is offered right now, and they try to bring into the school new languages and new techniques and new tools that are benefiting our students and the outcome for a successful architecture and design students in exploring territories that, you know, are not yet in front of us or will be part of our future.
So your students usually, after this university, where do they find employment?
The incredible part is that we are creating new employments and new opportunities for employment, creating new professional paths that didn't exist before. So, for example, an expert in digital technologies with the application of those sophisticated machines, it is a bottom-up research, especially from the firm that is hiring our students, because they upgrade the office through the experience and through the knowledge and the skills of our students. So we are very proud that we are anticipating career paths that are not existing yet.
You are designing not only objects but jobs and lives in a way, and the way our society is working, because yes. And this is, I think, great when education is able to be creative and not just to replay what the previous generations left us. I have seen a very interesting, some very interesting machines where laser is used. Can you tell me something about them?
We have a range of machines, not just 3D printing as a technology that we apply in our studios. We have also laser machines, we have CNC machines, we have thermo vacuum, we have a number of tools.
And how laser machine work?
Laser machines are very simple, actually. We use those since years. It's nothing new. Mm-hmm. It is the beginning of a design process that is related to fabrication. Very easy to adapt what the student is doing in the computer to something that is actually fabricated with simple materials. Can be cardboard, can be wood, can be plastic, can be is immediate, the outcome from a laser machine. And you can play through layers, you can play through complex geometries, but they are mostly in 2D, in 2 dimensions, that can be assembled and create a 3-dimensional object. So the student is facing the laser machine really in the beginning of the process of a design.
Did I understand well, did you speak about food?
Food. We 3D print. Food is about 3D printing, and we have faculty interested in that. And maybe we can talk about later with Professor Pongratz, what's his idea to 3D print food, and again, material and technology and the type of machine and the outcome that you want to have through that machine can really be related to the materiality and the geometry and the complexity of that geometry. And food can be an interesting path of research for 3D printing.
And how can, I know that New York Tech is very interested, involved in the issues of recycling, sustainability, etc. How are they related, this issue and the new printers, the new technologies?
Yes, sustainability is part of all our programs, graduate, undergraduate, master programs, but also the Bachelor of Architecture, which is accredited, until the Master of Architecture accredited, plays an important and significant part in our education and in our architecture, particularly programs. We cannot teach without thinking about sustainability as something embedded into the culture of the school as well. How we can think a better future through the spaces that we design, through the materials that we use, and through how we inhabit space and our behaviors, because that's important to change that too. And so with our students, we try to, because I believe that education is an important platform to educate our students to be more responsible and to be really with a civic engagement. And
can these printers work with recycled material?
Yeah, recycling can be design. We can design through recycling or vice versa, using recycling as an opportunity to design new landscape and a new ecology in our city, and the regeneration of our city, the resilience of our urban context is strictly related how we can think and how we can apply ideas of recycling in what we do and in what we design.
So, for instance, you can use 3D in order to produce an object with recycled
materials, like plastic can be recycled.
Exactly, and in this way you are actually upcycling, you could say, the material that you have. My last question is about, you are the Dean of the School of Architecture and Design.
Yes.
How do you see the combination of these two worlds and these two horizons?
I don't see them disjuncted at all. I see that they are intersecting each other and they are supporting each other, and I love that infusion. I like that permeability between one and the other discipline to connect what we do with different perspectives, and it's not just a building. There are so many aspects that design can enter into a space. So definitely we overlap, we intersect, we collaborate, students participate in programs,
in both of them.
Interdisciplinary programs where different disciplines are welcome to collaborate. Architecture is collaboration, design is about collaboration, it's about our lives. And
can I say, since we are Italian and we are also proud of being Italian, we have a very long history of this collaboration from the time of Gio Ponti, I mean, who designed the buildings, but also furniture, everything which was inside the building, and there was a dialogue between design and architecture.
Absolutely.
And also design, in a way, was architecture.
Absolutely. Miss Van der Rohe says that it's more complicated and there is so much to think about designing a chair than a skyscraper. You approach differently the scales of the object or the building or the city. There are so many implications.
But also fashion. Ferré, for instance, was an architect. Also, a dress can be a masterwork of architecture in a way.
I'm glad you mentioned fashion because I was just reading how biomaterials, not just in architecture, but are also inspiring fashion. Algae or fungus or mycelium are all materials that are similar to fabrics. They have these fibrous properties and they are used in fashion. And at this time, I think there are a lot of research going on those biomaterials. And our 3D printers actually can benefit from experimentations with biomaterials. We are pushing that research as well.
This is fascinating. Biomaterials that are also techno-materials.
Techno, bio, smart, intelligence, interactive.
This is why I suggested the new name of New York Biotech.
That
because
would be a great
you are
suggestion.
really intersecting these two fields that were so far from each other. If you think about futurism, they considered nature as a sort of antagonist, and in this century now, in this millennium, we would say, we have, on the contrary, an intersection between nature and technology.
Absolutely.
It's a new civilization, we could say.
It's about wellness, it's about well-being, it's about health, being healthy, have a lifestyle that is healthy and safe. And let me add that the two new Master of Science that we just opened related to the grant that we received from the IDC Foundation, and Alessandro Melis is our first at New York Tech endowed chair in computational technologies. We opened those two new Master of Science, and one is about health and design. And they both promote collaboration with our medical school that we have here at New York Tech. And there is in plan a bio center that will be built here in this campus in Old Westbury. And we definitely are collaborating with the School of Medicine, with the School of Health Professions and Architecture and Design in trying to see how we can be protagonists of our future, or the future that we want to have, more sustainable, more healthier, and safer for our communities.
Can I ask you a very easy question? I mean, this would look as from outside, I mean, as a very male university, profession, technology, etc. Did you have a change in the last years in the relation between the percentage of male and female?
Yes, diversity, inclusion, equality, they are all essential in our education and in our approach to education in our school. We increased the female percentage in our students nationally and internationally. We are not yet 50-50, while we are getting closer, but the good part of it is that the culture of the school is changing and is embracing that effort in trying to address inclusivity and diversity every day, and not just with a few activities, but every day as part of our culture. And female students are very often now leading teams, They are in leadership positions, in student organizations. They are very proactive in proposing new ideas and activities and initiatives. I myself, I am dedicating my entire career and life in promoting women in our profession that is still dominated by a male presence, but we have to work together to do that, and it's not coming from one single person, it's coming from the community and the culture and the change that we should perceive and do.
I'd love to meet some of your team. Who are your major collaborators? We are going, I think, to meet some of them.
Absolutely, that would be a great pleasure to introduce you, Fabio, to our fabrication lab director, Professor Dustin White. We also have Professor Christin Pongratz. He's the director of our Master of Science in Health and Design. And we also have Alessandro Melis, our first endowed chair at New York Tech, an endowed chair in emerging technologies. And please come with me, I will introduce you to them.
Thank you.
My name is Dustin White, and I am the Director of Digital Technologies and Fabrication at the New York Institute of Technology School of Architecture and Design. And today we're in the newly renovated fabrication lab. It's an exciting new lab where we have a number of different kinds of tools here. We have a range of desktop 3D printers, both large scale, small scale, different types of materials. We really give the students and faculty a lot of alternative material options to produce parts in both plastics, carbon fiber, resins, ceramics. We also have a number of different materials that we can apply to our new robotic arms in our robotic lab. The sound that you're hearing in the background right now is our large format WASP 3D printer. This printer is capable of printing building components, furniture, and a number of different projects that students and faculty might come up with.
My name is Christin Pongratz. I'm a professor of architecture here in the School of Architecture and Design at New York Institute of Technology, and I'm the director of the Master of Science in Architecture in the specialization of Health and Design. So one of the aspects that are very important for us in health and design is materials and the relationship of materials, let's say, to an environment, and in particular also how materials impact an individual's health. And with that we do research into biomaterials, materials we can recycle or upcycle. And what you hear in the background is a series of 3D printers of various types. So we are here in the digital design and fabrication lab, so to say, of the School of Architecture and Design. And our students have tons of opportunities here. They can work on 3D printers that have paste extrusion, plastic filament extrusion. We have a variety of materials we can fill in. And one of the machines we have here is from WASP. Is an Italian company, and they are known actually for natural materials extrusion. We call it clay-based ink. And they are in a collaboration with us. So we collaborate with WASP in Italy, in particular on natural materials, clay-based ink. And we, with that, have the opportunity to work on various scales. So small scales, product design scale, and we want to move up to building component scale and full building size scale. And the technology we can see here in the lab is very advanced and allows us to also use actually other materials as well. So we bought several machines from them, and we are, as I said, in collaboration with them, sharing expertise. And the research we are doing here is actually supporting their development of technology and equipment. And we convene here today because we talk about our current preparation for an exhibit. The title is Upcycling. And I give you maybe a bit of a more background for that. So In the UK, very recently, the Friend of the Earth talked about the resource consumption in construction is about 31%. Instead, research study in Finland said that we are about 50% of resource extraction globally for the construction industry. Yeah. So what is clear here is that the natural resource consumption in the construction industry has increased 80% since 1980, and it has accelerated since 2000. In the US in particular, the construction and ultimate demolition of our buildings accounts to 165 million tons of waste annually. So that gives me a bit of a background when we talk about scarcity of materials, and we talk also about how do we move on with an industrial paradigm that is built on taking resources, making stuff, and then wasting in a very linear fashion. And instead what we want to talk about is how can we move to a circular design, a circular industry, where we actually we make stuff, of course, we use it, but then actually we think creatively about it, we reuse it. And that actually then can run in a cycle many times, and so we actually think then about resources in a much more sustainable fashion. And maybe to quote the Ellen MacArthur Foundation, they actually came up with the term circular economy or circular design, and that's actually what we all as architects and designers have to think about. It's really key, I think. And also is true that of the construction waste we have, not really very much moves to landfill. A lot of it is actually maybe kept separately, but we don't really talk much about reuse, upcycle, recycle. It's very new terminologies. And so the question is, how do we get to the mode of rethinking or changing our mindset and moving into what we call really a new process of circular design and circular production. And so here in this lab here today, we have a series of prototypes that we are speculating on how we could rethink some of the processes. We move from the natural stone industry. So we have some samples that we show here today. We talk about recycling of stone. So it means stone gets scrap material, discarded material, gets collected, it gets ground down, it becomes powder material, then we add binders of various sorts, and we get new types of materials in block form or in slab form. We use here or collaborate with a company in Italy, so Pima limestone is pietra pugliese, as we say in Italian, so Puglia stone, and we use their material and we think how we can use recycled stone in a new way creatively. Then we collaborate with a company here in Long Island. It's Precision Stone, and they also have a lot of scrap material that we are collecting, and we also move creatively and rethink, so what do we do with scrap material? How can we enhance its value? What can we add to it? And what are the methods and processes we have to invent? And so you see some experiments with biomaterials. Could be another layer of functionality giving to that material. And what you will also see here is a combination then of other materials. For example, we work with the Italian company Wasp, who is, I would say, a world, maybe global known manufacturer, in particular of what we call clay-based ink. And they became famous maybe 10, 15 years ago. They started building originally 3D printing machines to produce 3D print clay on a very small scale, tabletop machines basically, and then they scale it up. So that's the key actually, how to scale up that 3D printing technology to become really revolutionary. And they built really large scale 3D printing equipment, and last year completed one of the first full-size buildings with a colleague architect of us, with that we have now evidence that we can scale what we learn, what our students here learn in 3D printing with natural materials, with clay, how to scale it up to full size. That means building components or even full-size buildings. And we are in collaboration with Wasp in that sense, acquiring the large-scale machines. And so our vision somewhere is that in the near future we can here in New York help those communities that we work with, underserved communities, in making housing maybe for them, making buildings that could be farms, could be using questions or asking questions of food and security, etc. So there's a lot of possibility in scaling up the technology. And maybe with that, I introduce my colleague here, Alessandro Melis, that also is working here with us, and give your thoughts maybe on that process that we're working in.
Thank you, Christian. I would like to take the chance to also to introduce the pedagogical methodology that we have been using here, because we have in the attempt to overcome the paradigm of artificiality and start thinking in ecological terms. So the big question is, can we build architecture which is intrinsically ecological, which in a way means, as my colleague was saying, can we do architecture which is embracing the circularity of the processes? And we think that this cannot be done without the contribution of the new generation of architects. So I would like also to introduce here the team of students and PhD researchers who have been collaborating with us in this experiment of reproducing an idea of architecture which is based on circularity and in a way that is more consistent with the idea of nature, which always operates in economy. So let's say that in an ideal world, waste doesn't exist, because in nature, waste does not exist. So I would like to take the chance to introduce our team of students and researchers. I would like to take the chance to introduce Domenico Lucanto, who is a PhD researcher collaborating with us in an exchange program between the University of Mediterranean in Italy and New York Institute of Technology. Domenico, can you tell us a little bit more of the process that you are...
The most interesting aspect of printing with clay now is the zero waste experimentation that comprehend a lot of process from the digitalization of the design through rediscovering the handcraft aspects in architecture and in the process that comprehend the realization of new components for the biological integration and for the ecological optimization. This machine can work with a lot of material. Is the WASP 1400, and we worked just with clay, and we improved the ecological aspect with other materials like moss, algae, and other like different kind of algae.